Hey everyone, this is Rich Mogull, and I'm excited to come to you today as the Chief Analyst of the Cloud Security Alliance. This is actually my first presentation in this role, so incredibly excited to be here and to dig into this content. And what I'm going to talk about today are the lessons learned, the things that we see world-class organizations using to succeed in their adoption of cloud. Now, where this comes from is I've been in the security industry for over 25 years now, and for the past 15 years have been really exclusively focused on cloud, AI, and newer technologies. Obviously, the AI part's coming a little bit newer. And one of the things that I've kind of learned in working with many hundreds of organizations, either in an advisory role or sometimes even doing some direct consulting with them or running training programs, is that we see some consistent things that these organizations do a little bit better than other organizations out there. And it's not that they had some magical insight; it's that they learned these things the hard way. Usually, a lot of these, world-class leading organizations, it's not that they're any smarter than anybody else. It's that they started earlier and they learned the hard lessons before the rest of us got to that point. There's a saying, I've seen it in aviation, I've seen it in safety regulations, like workplace safety, that every regulation is written in blood, that every line item that we have, every kind of rule, every requirement that we have in place is because somebody made a mistake that probably didn't go very well. And that's what I'm drawing from as we go through the materials today. And I kind of get into what has really created these world-class leading organizations. What are the lessons that they learned the hard way that we don't have to learn the hard way because they already did it for us, and we can extract those and we can use those to improve our operations. An example of this is that we have no shortage of tools and technology for cloud security today. And when I first started, we did. We had to write our own tools. I had to go back and relearn how to code again, which I hadn't done in a long time. But these days, there's no shortage of tools, both from our cloud providers as well as from third-party vendors and providers. And yet we keep finding that it's the same problems crop up over and over again across all of our organizations, leading to our security incidents. Now, so these are some statistics I've actually pulled here from Amazon and from Google and from Datadog. And consistently across, at least from those threat reports that they've released, we see that exposed credentials, usernames, passwords, access keys, tokens lead to the vast majority of cloud breaches. Now, finding and reducing the risk of these is fundamental to every security tool we have, and yet it's still something that we struggle with. And why is that? Well, it's not that high performing enterprises have any better technology than the rest of us. It's that they have better habits. They are better able to use these and integrate them and have better processes. And that's what they use to reduce their risk. And they don't eliminate their risk. Even the best organizations out there still have problems with static credentials in different places, or attackers finding ways to get their hands on those and get into the organization. But overall, they do have those better habits, and as a result, they carry less risk. Now, let's start from why is cloud tend to be more challenging to us than what we were used to in the data centers. This is where I came up with this idea. I call it the grand unified theory of cloud governance. You can tell I'm an egotistical analyst with delusions of grandeur because I name things grand unified theory of cloud governance. Well, this is something that hit me somewhere around 8 to 10 years of working with organizations, and particularly ones where I was kind of doing more of these in-depth projects and helping them build their security programs, and particularly for the enterprises that were the larger ones. And what I found was there were certain consistent issues, largely around governance, that these organizations were struggling with. And I realized that it was because of three factors. The first is, if you look back at how we've built most of our security programs and processes and frameworks, it's relied on the inherent scarcity of data centers. We build in data centers, we build in offices, and not any random application team can run in and plug in their own servers and stand up their own networks. We have four walls and we only have so many racks and so much power and so much wires and so much bandwidth. And as a result, a lot of our security processes and our teams and our organization structures were built to fit that model. But then cloud comes in and it blows the whole thing up. Because in cloud, individual teams can build and manage their own infrastructure. They're doing it virtually on the cloud providers using credit cards or, billing accounts. Not only can they have the ability to do that themselves, but they can now also do it programmatically using infrastructure as code. So all of a sudden, building the infrastructure becomes part of the application stack itself, and it's very accessible and understandable to these development teams. So we have these decentralized operations. We don't have to go to a networking team to build a network or a workload team to build a workload. In high performing organizations, they let the application teams do that themselves. But from a security standpoint, there's a challenge there because even though that's highly decentralized with everybody doing their own thing, the attack surface is pretty darn unified. Console.aws.amazon.com, portal.azure.com. I can't remember Google's offhand or Oracle's or anybody else's, but you understand what I'm saying. There is a single user interface and a single set of API endpoints where we're running all of these things. And the attackers know that they can go, and if they can find credentials, they know right where to take them to figure out if they have access. It's kind of what I call um, basically you don't have to be a targeted attack. If they get those, they'll figure out where those go. So we have our decentralized operations, we have our unified attack surface, and that attack surface, it's on the internet, protected with many cases nothing more than a username and password. And the resources we deploy there, because they're deployed on the public internet, without us putting now again, they don't default to public, but they're sometimes one click away from being exposed to the internet, just one or two misconfigurations away. And so this is really challenging because it changes how we have to think about our security and how we have to model our security. This has led to tools and programs like this one, the Cloud Security Maturity Model. So, hey, spoiler, I wrote it, so I'm biased. I like it. We did it. It's released here through the CSA. But what I like about this and where this came from was we realized that there was not a cloud centric view of how to build your cloud security program that was different from extending our existing security controls and frameworks. And those aren't wrong. Those aren't bad. Those don't go away because most of you, if you're working at the enterprise scale, you still have all of that traditional stuff you need to worry about, but there was a lack of a cloud centric view. And we're now on version 2 of the model, which was built largely from the things that we saw out there working with organizations. What was more successful? What was less successful? Where did they spill their blood learning the hard lessons? And could we tell the story to reduce how hard it was for everybody else to take advantage of that? So look, I can't cover all of that. I can't even come close to covering everything that we see in those high performing organizations. But there are 4 practices that I can spend some time on that I do think can help any organization move the needle, that any organization improve their cloud security relatively quickly. These are the ones that I think are more impactful, and they, of course, start with governance. I once said on one of the social media sites that shall not be named that all cloud security failures are IAM failures and all IAM failures are governance failures. Now, of course, that's an exaggeration. It's the kind of thing an analyst would spew out on social media, but there is some truth to it. And I do find that, I'm more of a technology guy. I love being hands-on. I like writing code. And yet the vast majority of the time when I was going in to do an assessment of an organization, the first problems I discovered were governance related issues. And to be blunt, 15 years later of doing this work, that is still the biggest source of problems that I encounter in organizations when I talk with them about their issues and when I'm going in myself to help try and fix these things. Now, in terms of governance, there's 2 pieces of that that I think are the ones that if you focus on now are achievable and will have the greatest impact. The first is to look at creating more of a cloud native organization and how do you actually organize and focus your teams around this. And then the second are the actual technical invariants, getting down to the security invariants and the code, which can be implemented across your cloud footprint in order to protect things. And I don't have time to go into like every little detail about how to build this, but there are characteristics that we see more consistently within cloud native organizations. They are things like don't use the same silos that you use for your data center. Allow more blended teams. Allow pulling out expertise. Now, of course, if you have a hybrid network, your data center networking needs to work with your cloud networking, but don't expect the same person to be experts across both of those, or even the same team to manage both of those. So you're kind of changing up your org structure and your process around that. The other is a shared standardization. You should set the ground rules, and I'm going to show you kind of my recommended way for doing that and then communicate that to those decentralized teams. So they all know the standard they need to work towards. And there can be some exception management and everything else, but that's also the one that you can audit against. And then you empower them with that decentralized management. Using things like security champions to make sure security is embedded into those teams, but not trying to route everything centrally where you start slowing it down so much that your cloud environment is slower to build in than your data center environment is. And I see that all the time. Another really big one is assign ownership and be clear about lines of authority. So going back to this identity and access management issue, which is one of our more consistent, having centralized policies and templates for how you're going to handle IAM, allow the team to design that, then you have security review and approve it, and then the team itself implements it, and then security audits it. And it sounds like a lot, but it's not. It's in many cases can be less work than what you're doing today, particularly with the kinds of tooling that we have. But that allows the team to craft what they need to get their jobs done. But security still has the authority to prevent the things like you just escape full admin, or more subtle things like, well, this S3 role for Amazon Simple Storage Service has both read capabilities and write capabilities in a way that could allow someone, if they got those credentials, to do a ransomware attack. Where if you split those into separate roles, because maybe the same thing isn't going to be doing both of that, or you lock it down with restrictions, then that might be something that can bring that protection in. So you're not making all the individual team security experts, but you have the security experts working with them, and you build in the checks and balances. Now, the other key one that I do see a lot as well is the split between production and non-production. And the more mature organizations for cloud security understand that anything with production data or access to production resources is production. It doesn't matter if you label it non-prod or dev. And really hate to admit how often I see that as an issue. So be really good about defining what is production and non-production. That way, you know that, you know what, even if this is a dev environment, if it has access to production data, it still should meet our production security controls because the attackers don't care. You can't hide your non-prod somewhere deep within multiple layers of your network. It's, as we talked about, that grand unified theory potentially out there on the internet. Now, the other piece is that we can back this up with security invariants. Security invariants are hard technical policies and controls in place that there shouldn't be exemptions to and can't be circumvented. And this involves being good with your cloud organizational hierarchy. So in Amazon, it's your organization and your organizational units, and Azure would be your tenant and your management groups. But using that and then applying your organization policies at the right level, and then building in the exceptions. For example, you can have one saying in AWS can create an IAM user except the role that's designated to the security team who's going to manage the exceptions. You build that into a service control policy. You never have to worry about IAM users. And you know that anyone that is being built by the right people who understand those security implications. Then being good with your identity-based policies, and then also your automation guardrails. Uh, every cloud platform supports these capabilities, and building these in early so that you're not having to run around and manage everything by exception, and so that you actually have consistent security controls in force, and that your invariants are different from your production and your non-production. And honestly, they get even more granular than that. If you do this well, organizations that do this well definitely have a much lower risk profile and have a reduced cloud attack surface. Well, let's assume we've got our governance kind of in better shape. We've reorganized a little bit, we've managed our silos, and you don't have to do a full reorg for that. I mean, a lot of the ideas I expressed are more about like shifting around some of the roles and the responsibilities and making sure everybody knows clearly who is responsible for what, and making sure that security is able to play their role and get things enforced so that, it's not dev running around without any controls on them. Security is there to let them move as fast as they can while still managing that risk. And then we have our invariants to encode to basically make sure that within our cloud, those rules are enforceable. And I'll be honest, I love this stuff because that is significantly superior to most of the capabilities that we have in a data center to consistently enforce security because it's built into the actual management plane of the cloud platforms itself. Well, the next thing is how do we focus our actual security controls? And I go in and I see people, they're pulling up like, and I'm not throwing shade here, like the CIS benchmarks, which are good, or some of the other standards or frameworks, but they're not prioritizing that based on what are the things that are going to cause us to have a security incident. And to a large degree, the rough estimate, I look at all the threat reports from the different vendors. I've done my own research around this. Somewhere around 80 to 90% of cloud native incidents are because there are static credentials, which can include tokens, or something was exposed to the public, like having a virtual machine, an instance, a container exposed to the internet without security controls in front of it. Those two things are the always in forever of the cloud security world, because that's been where all the problems in the early breaches that I encountered happened, and it's still the greatest source of breaches. Except now the attackers have become more advanced, particularly around going after these credentials. The info stealer malware out there now knows to look for things like long-lived Azure tokens or Amazon access keys. And those are available in places like Russian market and the other underground marketplaces. And there's whole automation platforms that the attackers use to take those and be able to compromise those. As we saw, for example, in the attacks against exposed snowflakes. Snowflake didn't do anything wrong. The credentials, well, they could have defaulted to MFA, but otherwise, it wasn't like a flaw in the platform itself. It was because those credentials were stolen and misused. And so it's really important for us to align our security controls against to close those threats first before we work about anything else. Well, how do the mature organizations do this? So they define those controls. They're in writing, both at the control objective layer, which we're going to talk about in a moment, as well as the specific technical controls for all the platforms that they work on. Then they use their tooling, their CSPM, their CNAB to track and identify the misconfigurations that can align with those top threats. They're also tracking the threat changes. And there are changes. So it used to be we didn't have to worry as much about some of those tokens. Now we know those are being pulled and utilized in these attacks as opposed to just going for the usernames and passwords because they know it's a more subtle way of getting into these organizations. And again, this is very different on each of the platforms, which is why you need to kind of track that. And then these organizations also are constantly monitoring their own instance to figure out where and how are we having problems. Then they use that to update their controls. And in many cases, where they're going to focus on is identifying the consistent issues. So I've worked with many organizations that get rid of like the AWS access keys and secret keys. And they did that through a combination of techniques, including using security invariants and their CSPMs to do that. And then they've run into other issues, such as things being exposed to the public. So they build in other automation and other guardrails to close down the things that they know are the sources of the attacks. These aren't necessarily, like I said, the closely targeted. These aren't the hard attacks. These are what I call those undifferentiated attacks to a large degree using automation tools. Another example is the going in and grabbing a hold of the cloud provider, keys to cloud provider's email services now and using that for things like spam and phishing. If you set your controls, tracking misconfigurations helps you make sure that you're compliant with those. And you're not looking at those misconfigurations merely as a spreadsheet that's sent out once a month. It really needs to be part of an engaged program. Seeing what the new threats are, seeing what kind of incidents you are detecting and responding to, and then feeding that back in to adjust the new controls. So the IR guys aren't running around seeing these same problems again and not passing that on to the teams that are responsible for fixing those. And one of the ways that we can actually build out and know what controls to build is by having really great control objectives. This is a diagram I stole right from the CCSK training. And we've had a version of this in CCAK and CCSK, if you know what those are, for quite a while here. The idea is you have a top level information security framework that defines kind of what are the buckets for our security controls. And it can be NIST CSF, or it can be the cloud security maturity model. Underneath that, we have our security policies, which is the human narrative about what employees are supposed to do. But then we get into the meat of this. And the meat is cloud security control objectives. Now, what do I mean? I've seen a lot of places that have really good lists of this is how we're going to do it in AWS and how we're going to do it in Azure. And to be blunt, these days, a lot of that's driven based on the security product you bought because they have, all of the controls that should be in place and they rate them critical and high, just like a vulnerability scanner. That's good, and that's a great start, but that's not really a full programmatic view. And that's where we can get into our control objectives. Control objectives are kind of a level up. A control objective is going to be provider agnostic. It's not tied to the specific technology. I like to say that a control objective is how we record our desired security outcomes. This is the security state we want to have, such as these here, which were pulled right out of the cloud controls matrix, employing least privilege when implementing information system access. This is the outcomes, what we should be doing. Well, this is a great start, and typically the CCM is a good place to start because it also does your compliance mappings. But I've found that most organizations need to apply these a little bit more customized to themselves. So here's an example. This actually comes out of the cloud security maturity model. I put in a bunch of KPIs within there. And this is getting a little bit more, down to more specific and can be customized even more. So what I like to do, for example, and what I've seen done in these organizations, you take the CCM, you break it out into tabs into, Yep. I'll just hold it for the rest into the domain areas that align with your cloud security framework. And then you get to customize these. And these align with your other existing security policies. And these align with the way that you want to do things in your organization. But again, they're not specific to your actual cloud provider. These are the outcomes that we want to build. And then you go back, and I'm going to go back in my slides here. Once you have your control objectives, these are the things we know we need to be doing. Then you write out the specific control specifications for how you do that on each one of those cloud providers. Here's how we're going to do it on, Amazon and Azure and Google and Oracle and Ali and whichever other cloud providers you're using. So then you get into the specific technical controls for each of them. Now, why does this matter? The framework gives you the big picture for your program. The control objectives tell you what you know you need to be doing, and then the control specifications tell you how you are going to do that on each of the technology platforms that you're working with. And all of that, when it ties together, it can be a beautiful thing. Now, the next is of the four things that I wanted to highlight is invest in your people. I, I had a saying years ago. I said, if you want to go multi-cloud, triple your security team. I have for real been hands-on with the console and the APIs of AWS for over 15 years at this point. My accounts date back to 2009, 2010. I've been hands-on with Azure for about 10 years. I feel pretty confident on AWS, but I learn stuff new every day that I'm working with it. Azure, I can kind of hold on by my fingernails, but barely, and I'm not sure I can spell GCP. There's nobody that's a multi-cloud expert. And one of the big problems that I see in organizations is that they're moving quickly into cloud and into multi-cloud. And again, I'm more focused on the infrastructure and platform as a service piece. Obviously, SaaS is a whole different ballgame, but they're not training people up or getting the right level of expertise, or they're giving it as other duties as assigned to an employee and forcing them to learn these new technologies almost in their spare time. And they have to learn more of them, multiples of these all at once. And the result is then how they do security becomes very tool driven because that's all you can kind of do. If you have to run with multi cloud, well, I'm going to buy a CSPM, a CNAM that's going to work multi cloud. I'm going to do what it tells me to do. But that's not really aligning with everything else that I talked about. That doesn't mean that you're able to understand, the intricacies of the IAM identity policies and RBAC policies. Doesn't mean you understand like the ins and outs of what are the best architectures for the network and how to build those in a secure way. You need to invest in your people. You need to invest in the skills and staffing for cloud specific, and you need to not make them learn every platform at the same time while still also doing their data center job. It's not going to work. And how do we measure the effectiveness of our program? Well, this is where we came out with tools like the maturity model, the CCM, the cake. These were all built by people that actually do this stuff for a living. Now, I've become particularly focus on the maturity model, not just because I wrote it, but I wrote in KPIs because it can be overwhelming when you're trying to use the CCM or the cake when you get started. And what we did with the maturity model is kind of try to build in control KPIs that are control objectives. So that's one area that you can measure is, am I meeting those KPIs? Another one is using your tooling. What are the volume of new and high or new, high, or critical misconfigurations? And you can categorize these by different types. Was it a manual change? Did it come from infrastructure as code? Like, what's the root causes of those? Because if we have our tooling and our security and variants and our training in place, we shouldn't have a lot of those appearing. And if they do appear, let's try and figure out why those are there. And that's the whole concept behind just culture. Don't have time to talk about it today. Look it up, but it's a really, I think, powerful approach to improving security in these cloud environments where things are decentralized and we have teams that have a lot more responsibility. And then we feed in not just what kind of misconfigurations and problems are we finding, but what are the actual incidents that we're encountering? What are the real world implications? And we again feed that into this just culture process using focusing on systemic process improvement instead of placing the blame. And that's it. I focus on four areas, and then I talked about in the end on measuring them. But governance, aligning with threats, being good about how you organize and build your controls, and investing in your people. These things are the habits that I see out of the world class, those really good organizations that do a great job with their security. And again, they're still going to run into issues. Nobody's perfect, and particularly at scale. But if you can build these into your culture, you are going to be in much better shape overall in terms of your cloud security. That's it. I hope you got something out of this talk today. If you have any questions, particularly if you're a CSA member, just hit me up. I'm more than happy to answer them and enjoy the rest of September.